This conference will now be recorded.
Okay, so guys, in the last session, we covered majorly on augmented analytics, right? The data discovery, data insights, etc. So now let's continue here and we'll go with predictive analytics. So predictive analytics, you all know, um, we have like three areas in analytics, right? Business intelligence, planning, and predictive analytics. Three major components in analytics. Okay, business intelligence deals with your historical data, getting your insights on the data, okay, discovering your data patterns and everything, right? So that those insights will help the business users in making decisions, right? So business intelligence is nothing but it's enabling the business users to uh, make decisions based on the data. It's like a data driven decision making. So then we got like planning, okay, so which always deals with overhead, like before head, like what is has to be done before, okay, so it will forecast and budget all the values. So then we also have the third component, guys, that is predictive analytics, which will use your historical data, which uses your historical data and predicts your future outcomes based on the data. Predicts future outcomes based on the data. That is predictive analytics. So earlier we used to have like some kind of an R statistical models we used to use to predict your future outcomes. You might heard a product. There was a product called SAS that was majorly used to do all the predictive modeling. But now with introduction of machine learning, right? Machine learning will act on your data, right? And come up with some decisions on the data, right? So it will actually now the entire end-to-end predictive analytics is now replaced with machine learning. Okay, so algorithms will work on the data, identify all the patterns in the data and predict your future outcomes based on the data, right? So right now the entire predictive analytics is done through machine learning. So you know SAP Analytics Cloud is a product having a lot of inbuilt machine learning algorithms, and you can do beautiful predictive analytics under SAP Analytics Cloud. Hmm. So generally we got three types of predictive analytics, guys. So if I speak about predictive modeling or predictive scenarios, we got three types of predictive scenarios. Wherever you go, you see only these three. It's not only SAC, wherever you go, you see three types of predictive scenarios. One is classification, second one is regression, and third one is time series forecast. Okay, so if your outcome is binomial, guys, yes or no, true or false, okay, so then we go for classification predictive scenario. Okay, you want to predict whether this customer will buy the product or not. That is a classification predictive scenario. You want to predict whether this employee will leave the organization or not. Yes or no. That's a classification predictive scenario. Whether this product will come to repair or not. Classification predictive scenario. Okay. So here you see, this is classification. So predict membership categories such as yes, no, true, false. So then you got, okay, regression, guys. So regression, in regression, um, see, in classification, your outcome is binary, either this or that. That's it. But whereas in regression, your outcome is continuous. It can be a number or an integer. Okay, so the most frequently seen predictive scenario, regression is the most frequently used predictive scenario, where you can predict your numbers, predict through numbers. Like you want to predict your revenues, you want to predict your marketing expenses, you want to predict your OPEX, okay, operating expenses, or you want to predict your discounts, uh, anything, any kind of it is used in sales, revenue predictions, marketing, okay, um, everything is done through regression predictive analytics. Cost predictions, everything is done through regression. Weather forecasts, everything, the entire stuff is predicted through regression predictive analytics. The most frequently used predictive analytics is regression. Then you got time series forecast, guys. See, time series forecast and regression are very much similar. They are very much similar. So outcome is continuous number or an integer in both regression and time series. The outcome is number. It is number or an integer. So both uses historical data to forecast or predict your future outcomes. Guys, regression is based on a lot of external factors, but time series don't consider any external factors. I repeat, regression is based on a lot of external factors. Time series don't consider external factors. Okay, so what does this mean? It's very simple. In regression predictive scenario, um, so guys, for suppose we are predicting your sales revenue based on a lot of external factors like number of stores operated, number of sales employees working, the marketing uh, amount spent on different marketing campaigns, okay, inventory available in different stores and warehouses. So if you're predicting your revenue based on a lot of external factors, then it is a regression predictive scenario. Okay. So, or if you're simply forecasting your future sales revenue based on your historical sales revenue without considering any external factors, then it falls into time series forecasting. Okay. So in time series forecast, it will simply see the trend of your data, whether your revenue is increasing, decreasing, or in a constant trend, and forecast your future values. And you don't consider any external factors while doing a time series forecast. Hmm? Generally, in planning forecasting, we make use of time series. Top line forecasting, we make use time series, but in other cases, you all see regression. So regression considers external factors. Time series don't consider an external factor. Clear, everyone? Makes sense. Any questions here? Okay, so let's get started. I'll start with classification now, and then I'll cover regression time series. All the three. I'm gonna cover all the three, but I'll start with classification first. Okay, so as I very clearly mentioned, if your outcome is binary, so you go for classification predictive scenario. I'll give a simple example here so that you understand classification. So guys, whenever you run any predictive scenarios, you should know them. So what's the need? What's the business need? Why we are going for the predictive scenario? What exactly the business need from that? And what they're trying to achieve out of this predictive model, and output expected by the decision we make. So three things determines our predictive scenarios. So you see, I come up with a simple thing like, suppose the company launched a product X. They launched a new product X and it was given a marketing fund of around 1 million USD. Okay. And the customer base of my company is around 15 million. So we got 15 million customers. And the marketing team is charging $1 to reach one customer. Okay, so but I got only 1 million, so I can reach only 1 million customers. If you don't have machine learnings, they will reach to random 1 million customers. So now what we do is we can actually create a predictive model which will divide your customer base into two groups, one who might respond positively and who might respond negatively based on different factors, based on the customer satisfaction, based on like whether customer has purchased the similar products in the past. Based on different factors, we'll divide your customer base into who might respond positively, who might respond negatively. Okay. Uh, right. So based on that, so we will actually so who might respond positively. Based on that, we'll try to reach only the customers who will come up with a positive response. It's not mandatory that who might respond positively will buy our product, but these are the most likely customers, okay, who might give a positive response to the product. Okay, that is how you predict simple examples of predict a scenario. Okay, so guys, generally, if we speak about dependent independent variables, uh, see, for suppose I have a data set like this. I do have a data set like this where I got patient name, patient age, the symptoms, and which this person has so this side written long back, so has COVID or not. So now I would like to build a predictive model which will predict based on the symptoms. It should predict whether this person is infected with COVID or not. So that is my agenda. In this case, what I do is we need to define what exactly is a predictor variable and what is an outcome variable. Okay. So in this case, I'll make has COVID or not as an outcome variable. So this is denoted with Y. So your outcome variables are, we also call outcome variables as dependent variables, and they're denoted with Y. So remaining all will become independent variables or input variables or predictor variables. We also call it as predictor variables. Okay. So they are denoted with X. So here patient name is X1, age is X2, fever is X3, cough is X4, like that. Whereas has COVID or not is Y. Okay. So what the system do is will use the historical data. We'll feed this historical data to the predictive model. Okay. To the machine learning algorithms. These algorithms will work on the data. Okay. They actually work on the data, create a predictive model. So this model gives like the relation of Y with all the X variables. So then what you do in the next cases, you simply load all the data like patient and the symptoms. It will predict whether this person is infected with COVID or not. System will predict it. Okay. If the data in this column is binomial, yes or no, true or false, then we'll go for classification predictor scenario. We'll see the data set, see what we're gonna predict. And if the data in that uh, is binomial, so we'll go for classification predictor scenario. If the data in this column is number or an integer, we'll go for regression predictor scenario. Very simple. Okay. So this is like dependent and independent variables. So guys, first let me come up with a use case so that you understand this. Okay. Right. So guys, for every predictive scenario, I'm gonna cover up with a use case so that you understand that predictive scenario in a much better way. Okay. So you should know the business need, the business goal, okay, and what we're trying to achieve, okay, using this predictive scenario so that you understand the predictive scenario in much better way. Okay. So guys, this is the need. I'll show the data also. Take it minutes time, read this up. Okay. You understand the so my agenda was to create a predictive scenario in bank marketing campaigns. Okay. Uh, just take a moment, read this up. Okay. Once you're done, I'll start creating a predictive model on this. Okay, so guys, this is the business need. So bank marketing campaign and term deposit. So now, uh, so generally for any bank, the deposits are the most crucial part, because to lend to the new customers, they need deposits, right? So the bank, what they do is they give loans to the customers, right? So they also need to borrow the money to give the loans. They can either borrow in two ways: one through deposits, which is low cost borrowing. What the banks they say is that's low cost borrowing. The profit margin is very high because they take the deposits at 6% or 7%, 6%, and they give the loans at 9%. High margins. Other ways they borrow from the markets at higher interest rate of 7%, 8%, and they give at 9%. So where the margins were very low. So for a bank to survive or to increase their profitability, so the deposit is very, very important. So a lot of banks, they do, right? They do all marketing campaigns. Okay. So here, first, due to competition, positive response rate to mass campaigns is typically low. If you run any mass campaigns, continuous calling, right now no one responds to the calls and everything, right? According to the recent study, less than 1% of contacts will subscribe to term deposit. Second, direct marketing has drawbacks, causing negative attitudes towards the banks due to intrusion of privacy and also cost and in order to save cost and time, it is important to filter the contacts to keep a certain success rate. So now we make use of this machine learning algorithm to identify which customers might go for a pause, will subscribe for a term deposit. Okay. So then we'll run, the banks will run marketing campaign only on those customers. So this is the objective. So predictive model objective is to build a classifier to predict whether a client will subscribe to deposit or not. Okay. So if the classifier has higher accuracy, the banks can arrange a better management of available sources by focusing on the potential customers picked by the classifier. Classifier in the sense predictive model. Predictive model predict, right? So these customers might subscribe to term deposits, so that these banks will focus only on those customers, right? This is the business goal, basic business goal. Okay, so now the objective of my predictor scenario are, okay, so I got two objectives for my smart predict: understand the reasons for term deposit subscription and identify which customers might potentially subscribe for term deposit. So which identify the customers who might subscribe for term deposit, and second, what are the reasons they're going for term deposits? That there should be some specific reason. Okay, so now let's look at the data. Let's look at the data once. Sorry, prediction rate. So here you see key is like mostly like a customer ID or something. 1 2 3, how many campaigns happened? So here you see we got around 30,000 campaigns happen. The age of the customer, the job category of the customer, what job category the customer do. So marital status of the customer, you see all the data, education of the customer, you see all customer details here. Whether the customer has loan defaults in the past, the customer has got housing loan, personal loan with the banks or not. So contact mode, how did we contact the customers? So when did we last contact the customer? Day of the week. Call duration, how many minutes we spoke with the customer. Campaign calls with the customer, days since last contacted. Usually all the rate, and previous campaign calls in the earlier campaign, previous campaign outcome. And if we can spoke to this customer in previous campaigns also, what is the outcome? So, and then there are some socio-economic indicators, guys, like employment variation rate. Okay, so these are generally you'll get a lot of deposits when your socio-economic indicators are in negative. Okay, So means for suppose your economy is not doing good, if there is high inflation, so obviously banks give a lot of what we say uh, right. So these are like socio-economic indicators, guys. See, if your economy is not doing good, if inflation is on quite high, consumer confidence index is quite low. So then what we do? So customers don't try to park the money in risk sectors like equity. They'll try to go for safe sectors. Okay, like deposits and other stuff. So there are two ways. You need to see it in two ways, guys. If inflation is quite low, economy is doing good, so then the company, the investors like to park the money in equity in the sense stocks, which will be quite rising. But if the economy is not doing good, stock market is not doing good, so inflation is quite high. If inflation is high, the bank will increase the interest rate, so deposits will be the safest option. So like that, the customers will rotate the money. So socio-economic indicators play a very significant part in the deposit rate, in the deposits. So like employee variation rate, consumer price index, consumer confidence index, these are like socio-economic indicators. Even Euribor average rate is like the rate at which one bank can lend from another bank, I think. Okay, this is basically data from Europe. So you see that's the reason Euribor average rate. Then you see the number of employees we have. So this is not term loan, guys. This is term deposit. I just need to change this. So whether these customers subscribe to term deposit or not. So you see three types of data. One, okay, the customer data, customer personal data, and the loans, customer personal and customer loan data, historical loan data, and the campaigns run on the customer. So what type of campaign was run? How many campaign calls was made? When did we last contact the customer? Then campaign details, and then you got some socioeconomic indicators at that point of time, and whether customers subscribe to deposit or not. You see few S here and there. So this is your historical data, guys. So I got around 30,000 marketing campaign calls, which uses as my historical data. So generally in predictive data modeling, you see two data sets. One is historical data and second one is current data. Okay. So this is your historical data. I'll use this data to create a predictive model. I'll use this data to create a predictive model. So then what we do is, I also have another data set here. You see current data set. I'll use the current data sets. So now this is my current data set. These are the employees which are yet to be campaigned. Okay. So now we are planning to campaign on this. So now we're going to predict out of this. We got around 10,000 customers. We're going to predict on this current data set. Means we'll use the historical data to create a predictive model. Okay. Then we'll apply the predictive model on the current data to predict the term deposit rate of that customer base. So on this 10,000 customers who might potentially deposit in the bank. Okay. Yeah, makes sense. Whom should we target? Any questions, anyone? So generally you see two data sets in classification and regression. One is historical data. Second, then we'll apply it on the current data. Okay. So guys, the model is created once, but it will be applied multiple times. Every time you have some new data, we'll apply the predictive model on the new data and see the predictive outcome on the data. So training predictive model is created once, only once, but can be applied on new data set again and again. Every month, for suppose you're getting new data, every month we'll keep on applying the predictive model on the current data. Okay. Make sense? Any questions here? So I have two data sets here. So you have these data files available in your what we say Google Drive base. You can check this up. So these files are available in your Drive, G Drive. Okay, now I'm going to make use of this to create a predictor scenario. Clear? At least on the case, business case, what we're going to achieve, what we are trying to achieve. Any questions, anyone? Okay. So now here I go. So generally, guys, we got 4 steps in predictive scenario, you see. So first, create data sets on historical and current data by importing data from file or external business applications. Right now I have the data in file. Even if you have data in external business application, get the data into SAP Analytics Cloud and create data sets on that data. Okay. Then we'll create a predictive model using the data from historical data set. We'll use the data from historical data set and create a predictive model. Okay. Then we'll apply this predictive model on the current data set to get the predictive outcomes. That is step 3. So then we'll build a proper story on. So generally now once you have the predictive outcome ready, guys, how we showcase it to the end users, business users, we need to show in form of a dashboard, right? So all the predictive data, all the predictive outcomes we get, we need to show it in form of a beautiful dashboard. So we need to build a proper story on top of your predicted data sets. Okay, so that's the reason, guys. Generally, you go to any predictive projects, you are asked to learn Tableau or ClickSense. The reason is, so once you have predictive outcome ready, you need to do the reporting on top of that predictive data. But in my case, SAC itself is a reporting solution, right? So we'll build a proper story on top of your predictive outcome. It's like a 4-step process, guys. So any predictive scenario like classification or regression you take, it's a 4-step process. Time series is a bit different. I'll discuss about time series, but classification regression, you see the same 4 steps. All right. So now what we do is I got 2 files. I'm going to import data from these 2 files and create 2 data sets. See guys, now we got 2 objects in the data modeling and data staging space. So you see, I got 2 objects in data modeling and staging space. One is data set and second one is data modeler. You got data model and data set. Okay, to stage the data, and you got two objects in data preparation. You got 2 objects in data preparation and data staging. That is data modeler and data sets. Okay, so guys, in most of the predictive scenarios, we make use of data sets. Data sets you majorly see using it in predictive scenarios only. You don't see much of data sets in business intelligence and planning. You all see data models only in BI and planning, but in predictive analytics, you see a lot of data sets. Okay, I tell you why. So guys, here you see we got 2 objects in data wrangling, means data preparation. One is data model and another is data set. And a story can be built directly on a data model or data set. You can build a story either on a model or on a data set. That's fine. Okay. So what's the difference between a data set and a data model is, see, data set has a data preparation tab. It has got a basic data preparation tab and minimum data wrangling option. Generally, in data model, you have 2 tabs, guys. One is data preparation tab and also the data modeler tab, right? You got 2 tabs. Means like first you do all the data preparation, and then you have modeler view, data preparation view and modeler view in data model. Okay. In the modeler view, you can set a lot of preferences. You can maintain your dimensions. Okay. And also you can maintain your job. You can also do a data management there. In the modeler tab, you can do data management like importing data, exporting data. Okay, and you can keep on continuously loading the new data into the data model. So one major difference, guys, between data set and data model is, so in data set you load data only once. That's it. You can load data only once. Okay, that's it. If you want to re-import, it will delete the entire data and re-import the entire data. For suppose, guys, you got some sales data, you loaded, you created a sales data set today. You want the new sales transactions were happening in the background. You want them, you need to re-import the entire data. But whereas in data modeler, you load all the data, and every day you can pull out the new records. You have the data management in data modeling. We don't have that kind of a data management in data sets. Okay, you don't see any data management in data sets. That's the main difference between a data set and a data modeler. Okay. So data set has got a data preparation tab. Just a moment, please. Okay, so yeah, that's the main difference between dataset and data mortgage. We don't have any data management in the datasets. So you see, dataset has a data preparation tab and some got minimum data wrangling options. That's it. Uh, so it is majorly used in ad hoc and ungoverned use case. Ungoverned means there is no, if there is no continuous data loading, it's not majorly used for reporting. Ungoverned, okay, there is no data governance here. So, and it is majorly used in predictive scenarios, guys. Datasets are majorly used in predictive scenarios. Okay. So what I'll do is first I'll use this files as a source and create some kind of a data sets on historical data and current data. Okay. And then I'll move on creating a predictive scenario. Okay. Let's start. I'll start with my first step, that is creating a data set on historical and current data. I'll go create a data set. So my source is CSV or an Excel file. You can create a data set by pulling data from file or from an external system. From data source means from an external system. Okay, and you cannot maintain any master, you cannot do any master data management also, guys, in the data set. Okay, you cannot maintain public dimensions, master data management. You'll see them in the upcoming sessions in the data modeling. So I'll take the data from CSV or an Excel file. So I'll take this file as my source, marketing campaign, current training data. So let's say import. Okay, I'll create a new folder here. I don't want to use business intelligence. I'm creating a new folder. Okay, so I just take it as smart predict. So here I'll create another subfolder, that is datasets. For all datasets, I'm creating a new folder. So in this smart predict datasets, I'm going to create this. So I'll write it as historical data here. So marketing campaign, historical data. So okay. So here you see, guys, I got the historical data. You can apply some transformations on the data. You can see we can apply all the smart transformations on the data. You can create hierarchies, level-based hierarchies. You cannot maintain the dimension management, like you cannot maintain attributes, etc. But remaining you can do. I told you, right? We cannot do data. We cannot do dimension management, like attributes, description attributes, those things. Mass data management we cannot do in this. You can create, if you want, you can create J enrichments, etc., etc. All right. So in this case, and you want to re-import the data, this is the option. In this case, let's identify. So guys, here key is identified as a measure. It's not a measure actually. I changed this to a dimension. Key is not a measure. I'm changing it to dimension. Age, measure, fine. Call duration, campaign calls, day since last contacted, previous campaign. Employee variation rate, is it a measure? Consumer price index is a measure. Consumer confidence index, variable average rate, number of employees. These all are measures. Fine. I'm okay. Remaining all I'm good. I just changed my key to a dimension. So here I go term deposit. Let's go to the dimension of term deposit. It is string and historical statistical type is nominal. It's binomial data. It's fine. Right. So I can just go save this up. I created a data set now. So yes, so we created one data set on your historical data. So let's create another data set on current data also. Okay, let's create another data set on current data. So let me create a new data set, same source file. I use current data here. I'll change key to dimension, remaining all fine. So I'll go save this. So now we're done with step one, guys. We created two data sets, one on historical data and second one on current data. Okay. So then what I do is I'm going to use this historical data set to create my predictive model. That's going to be my step two. So let's work on step two. Okay. Hey, just give me a minute, please. I'll be back in a minute and I'll start working on predictive model. Just a minute, please. All right, guys, now let's go create a predictive model here. Cool. Predictive scenarios. So we'll go with classification because I'm going to predict whether the customer will subscribe to term deposit or not. It's yes or no, right? It's binominal. So I'll go with predictive scenario classification. So in smart predict, I'm going with bank marketing campaign classification predictive scenario. So okay. So you can give your own description, guys. So and here you need to give your training data source. So guys, we generally give our entire our historical data as a training data source. Okay. So whenever we give historical data as a training data source, guys, it will split your data into two. It will split your historical data set into two. One is training. Uh, one is training data set. Another one is uh, sorry. Okay. So it will split your data into training data and validation data, guys. Here you see. Whenever you upload the data, it will split into train and validation data set. System will do that split. Okay. So almost 80% of the data used for training the predictive model means so this data is exposed to machine learning algorithms. These algorithms will work on the data, create a predictive model out of the data. Okay. And that predictive model will be validated using the validation data set to find the accuracy of the predictive model. To find the accuracy, it will be validated, okay, using the validation data set. Here you see. So if you feed any historical data, guys, it will first system will first split the data into training and validation data sets. Almost 80% of the data is used for training only. Okay, so this training data set is exposed to the algorithms. These algorithms will work on the data, create a predictive model out of it with a logic, and then this model will be validated. Where you have the actual results, it will do the predictor result and identify to get the accuracy of the predictive model. Okay, it is used to get the accuracy of the predictive model validation data set. So here also your training data set, which you got around 30,000 odd records, right? So this will be split into training and validation data sets. So here system will do that. System will actually do that. We got nothing to do here. System will do the split. Okay. So training data source, I give my historical data as a training data source. Edit your column details. So guys, here you got key, right? I'll make this as a key. Okay. This will be like a unique identifier. Okay. And it will not have any impact on your predictive model. Then C. Okay. So guys, here I'm gonna predict my term deposits. Okay, so it should be nominal. The statistical type is nominal. Yes, it is nominal. Fine, I'm okay with it. Statistical type should be nominal here. So okay, save. So given the training data source, get my current data. Here you should identify your target. Okay, what you gonna predict should be your target. I'm gonna predict term deposit. In the future, I'm gonna predict the time deposit, so it will become my target variable. Means this will become your dependent variable or target variable. Remaining all will become your predictor variables. I told you, right? So now here term deposit is y, remaining all are x. This is X1, X2, X3, X4, like the job category is X3, marital status is X4, education is X5, like that. So whenever we expose this data to this, whenever you expose the data to the algorithms, guys, these algorithms will try to identify how different factors influencing your term deposit, how employee marital status influencing term deposit, how employees job category influencing term deposit, how Euribor rate impacting term deposit, how consumer confidence index impacting term deposit, like that. You'll see how different factors impacts or influence your term deposit. Okay, so that is what you see, right? I given my predictive goal as term deposit. Fine, so this will be y and remaining all will become x variables. And then in the influences, guys, here whatever column you select, that will be excluded as an influencer. Okay, so what columns you think might not influence your target, right? They should be excluded. They should be excluded, guys. Okay, here key is anyway, I given it as key, it is by default excluded. So I think, does age impacts your deposits? Yes, obviously, right? We get a lot of deposits in the late ages, guys. Young generation don't do deposits much. Okay, they always try to invest in other categories. Okay, age is a factor for term deposits. I don't think call duration will impact your deposit. It's not a right parameter, so I'll remove call duration. So whatever you select, that is excluded. Okay, so number of campaign calls, not sure they impact or not. Let's see. So last day since last contacted, previous campaign calls, they all will impact your term deposit. Employee variation rate, consumer socio-economic indicators play a big role in the deposits. Okay, so they all will influence your term deposit. So number of employees, the bank has got nothing to do with your term deposit, right? So the customer is not worried, right? The bank has got 1,000 employees or 2,000 employees. Job category of an employee might influence your term deposits. Like if he's high paid, he might be having a lot of savings, he might deposit. Marital status also, some people look at safety after marriages, so it also might be an influencer. Education is an influencer. So this person has loan defaults, these also influence your deposits. Okay, if he's already in loan default, he will never do a deposit, right? Okay, first he'll clear off the loans. Contact modes, yeah, there might be sometimes contact mode also influences the deposit success rate. Last contact day of week, previous campaign calls. I'll select everything, guys. I'll select everything. Apart from call duration, number of employees, I select everything will influence my term deposits. I select. You can also limit your number of influencers, guys. You can limit number of influencers to 10. It will select only the top 10 influencers. Right now I'm going with everything. So I given all the details of my predictive scenario. Now let's go train your predictive model. So as I very clearly mentioned, SAP Analytics Cloud is a product having a lot of inbuilt machine learning algorithms. So guys, we got a lot of ML algorithms, okay, inbuilt in under SAC. Okay, but how does the system know which algorithm to pick for this scenario? Which algorithm will work perfectly in this scenario? Okay, but suppose guys, we got, imagine 10 algorithms under classification predictive model. Imagine we got around 10 algorithms under classification predictive model. So when you click on train, what happens is this data will be exposed to all the 10 algorithms. This data will be exposed to all the 10 algorithms. All the 10 algorithms will create their own predictive model. Okay, and all these predictive models are validated, and the model with the highest accuracy or the best output will be given to the customer. So as system or you don't know which algorithm to pick for this business case, data will be exposed to all the algorithms. This happens in parallel. So all the algorithms will work on the data set, create their own predictive model, and that models will get validated, and the best fitting model will be given as outcome. Okay, so that is the beauty with SAP Analytics Cloud, and this all happens in the background. Okay, all right, now let's go train your predictive model. It will take some time. Let's wait. Okay, guys, there we go. So you see, prediction confidence of this predictive model is 97%. Means prediction confidence is if you give the same data set, how likely we get the result. 97% chance we get the results. That's fine. The biggest thing you need to see is predictive power of a classification model. So for my model, it is 62.65%, which is acceptable range. 62% is okay. Okay, good predictive power only. Means, so what are the prediction we do? It is that will be 62% accurate. Means if the system give 100 customers as yes, out of it 63% might be correct. That is the predictive power. So here you see in the training data set, the system has split your data set into training and validation. In training data set, 11.5% customers has deposit as yes and 88.85 has no. In validation also 11.3 is yes, 88.7 is no. That's fine. And here you see how different factors, these are the major factors. Key is influencing. Key should not influence, guys. Key should not influence. Why key is influence? Okay. So guys, key should not influence. In this case, what I do, I go to the details. I'll retrain the model. Let's retrain. Okay. So now I got 61% predictive. That's okay, fine. So here you see influence. So Euribor average rate, employee variation rate as the top factors. Then we got contact mode, consumer confidence index. Everything is fine. Okay, so these are the top influencers, guys. And here you see, so this gives you, see guys, if you have perfect model, you'll identify all the customers. And if you, so this is like red line is random sampling, guys. Blue line is our validation curve. Green line is a perfect model. If you get perfect model, this is how you green line. Okay. So one thing, if your blue line is more inclined towards green, that means your model is more sophisticated. If your blue line is more inclined towards red, your model is less sophisticated. Simple. Okay. So in my case, it is okay. The blue line is more inclined towards green only. The area is less when compared to this area. That is okay. Means red line is random sampling. If you don't have machine learning, for suppose I'll put this way. I got around 11.2% customers who are depositing. Means, for suppose I got 1,000 customers, guys, out of which some 110 customers are willing to do a deposit. How do you identify that 110 customers? If you speak to 500 customers, means 500 population, okay, 50% of the population, you will identify 50% of the customers who might take, like 55 customers who might take the deposits. If you speak with 100,000 people, you will identify all the 115, 110. But in case of a perfect model, okay, if you speak with 12% of population, means 120 customers, there is a chance that you will identify all the 110 customers who will take the deposit. That is a perfect model, guys. In our case, if you speak with 130 customers, 13% population, means 130 customers, there is a 48% chance you'll identify, like 48% of 110 is around 50, 54 like that, 52, 53. Okay, you'll identify 52, 53 customers, okay, who might potentially take the loans, sorry, deposits. Okay, by speaking to 130 customers like that. That is how you see. That is the difference. That is how it works. This is what we call it as RSC chart, guys. This is our RSC chart. So this gives you how sophisticated your predictive model is. If this blue line is more inclined towards green, it is more sophisticated. If it is inclined towards red, it is less sophisticated. In my case, it is good. I don't say super model, but I say it's a good model. All right. So now I go on to the influencer contributions. You see how different factors influencing your uh, uh, this one. So if you see how Euribor average rate is influencing, if I just go here, I'll pick Euribor average rate. Okay, when your Euribor average rate is quite low, then you see the deposits were quite high. There is a 45% deposit, and we got 10% customers in that average rate. Means so generally, if this Euribor average rate, and this what is this Euribor average rate is? It is like the interest rate at which one bank can lend to another bank, I think. Okay. So Euro interbank offered rate, this is the interest rate which credit institutions lend money to each other, which is often referred as a price of money. At what price they're getting the money. This is benchmark rate at which banks lend or borrow excess reserves from one another over a short period of time. Okay, so I can clearly see, guys, if this rate is quite low, so it is attracting lot of deposits. Maybe, guys, if we have high inflations, these rates are quite low. Okay. Here you see. Okay, if it is 1.5 to 81, so you see the 17% like this. So the Euribor rate is low, so we see a lot of positive rate, okay, on the deposits front. So that is how Euribor rate is influencing. So it's a socioeconomic indicator, guys. So generally, I think if Euribor rate is low, that means interest rates are quite high. Okay, I think this is reciprocal to interest rate. If interest rate is high, you'll get high return on the deposits, right? That might be the case. Okay, I think Euribor rate is uh, inversely proportional to the interest rate. Then I can say employee variation rate. If employee variation rate is Okay, if employee variation rate is quite low, then you see a lot of deposits happening. Means if employee variation rate is low, economy is not doing good. If economy is not doing good, so the most of the investors try to go for safe route options like bank deposits. They don't invest in equity. If economy is doing good, if employee variation rate is around 1.1 to 1.4, the frequency of positive target is only 3%. Only 3%. So I can say, so if employee variation rate is negative, so then you can attract a lot of deposits from the customers. These are like how these are socio-economic factors which influencing. Then you see contact node. Okay. So guys, if you call on cell phone, the positivity rate is 14%. If you call on telephone, positive rate is only 5%. So it should be preferred mode, contact mode is cellular phone. Then you see consumer confidence index. Obviously, if consumer confidence index is low, you'll see more deposits. Find last contacted month, day of week. Okay, let's see day of week also. If day of week is Tuesday, Wednesday, Thursday, positivity rate is quite high, and Monday, Friday, the positivity rate is quite low. So it is always ideal. Now it's ideal to do the campaigning on Tuesday, Wednesday, and Thursday. Then you see age. So you see how different factors impacting your term deposits. Here you see age. If age is quite high, guys, you see a lot of deposits happening. So obviously senior citizens go for bank deposits, right? That's what you see. You see bank deposits in 7 to 29 at the teenage level and also at the high age. Medium, you see very less. So this is how you see different factors influencing your term deposits. So and then yeah, maybe I'm already out of time, guys. I stop here for today. So in the next session, I'll speak about confusion matrix, performance curves, and also I'll run these two. Like I'll apply the predictive model on current data set and also create a story on predicted data set. Okay, stop here. Thank you all. Have a great day. Thanks so much.